Now my student, welcome back to in our presentations, and for this time we're going to look different questions which you can appear as wave velocity concern, and we're going to start with example number 1. Example number 1 is here, and it is saying okay, sorry. A wave path in a string moves a distance of 10 meter in 0.05 second. 1. What is the velocity of the path? Second, what is the frequency of a periodic wave on the same string? Remember, on the same string if its wavelength is 0.8 meter. I'm repeating, a wave path in a string moves a distance of 10 meter in 0.05 second. 1. What is the velocity of the path? Second, what is the frequency of periodic wave on the same string if its wavelength is 0.8? Now my students, let us go back to our example 1. And remember, for you to go smoothly, you must start with the given data. What do we have? A wave path in a string moves a distance of. Therefore, we have distance, which is x, but you must write distance. Let me write here. Distance, which is given by which symbol? X is 10 meter. But time taken to complete this distance, time, which is in t, is 0.05 seconds. After there, what is the velocity of the path? But also have been given wavelengths. You can write wavelengths here. Wavelength lambda is 0.8 meter required. What have been required to calculate? 1, let me change here. Have been required to calculate 1 velocity of the path, which is v now. Solution. You see my steps? So how can we calculate the velocity? For the data we have, velocity will be very simple. If you are going to use v is nothing but distance of time. What is distance? 10 meter. What is time? 0.05 seconds. What is the answer? You take 10, use your calculator. 10 you divide by 0.05. What is the answer? 200 meter per second. Remember, the SI unit of velocity is meter per second. Therefore, the answer is 200 meter per second. The second question was asked to calculate. The second part is asked to calculate frequency of a periodic wave on the same frequency. Required what? Second frequency, which is given by f. This is very simple. Solution. So long as we have velocity through calculation, remember the key concept was on the same string. Because the string was the same, that means the media was the same. The velocity you have calculated is the one which you are going to use. Therefore, velocity we have, wavelengths we have. Therefore, it is simple now. Solutions. You must start from the general equation, v lambda f. After writing the general equations is now where we are going to make f the subject. Then f will be equals to v over lambda. Remember, here will be awarded marks, here also marks. If you are going to write straight from here, that means we are going to lose these marks here. Therefore, what is velocity? 200 meter per second. What is lambda? 0.8 meter. Now what is the answer? 200 you divide by 0.8, the answer is 250 Hz. Therefore, frequency of the pulse is 250 Hz. Do you see, my students? Yes, this is how it is. Very, 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 very simple. Now let us go to the second example. Let us go to the second example. Example 2. Example 2. Let me lab my things first. Example 2 is coming to you, don't worry. Just wait. Here it is. Example 2 is coming. Here it is. How is it say? A body vibrates with certain frequency, sent waves 2 meters long through a medium A and 1.5 long through a medium B. Now, did you see this question? Yes. It has two medium, A and B. The velocity of wave in a medium A is 10 meters per second. What is the velocity of the wave? What is the velocity of a wave in medium B? Let me repeat. A body vibrating with certain frequency, which is an unknown frequency, sent waves 2 meters long through medium A and 1.5 meters long through a medium B. The velocity of wave in medium A is 10 meters per second. What is the velocity of wave in medium B? Okay, now we have two media here. Given, we have two medium. We have two medium. We have medium A and we have medium B. A body vibrating with certain frequency sent a wave 2 meters long in. Therefore, distance covered, which is now wavelength, is 2 meters in medium A and 1.5 meters. Let us assume in medium A is 1, in medium 2 is 2, in medium B is 2, 1.5 meters. The velocity of wave in medium A, now V1 is 10 meters per second. What will be the velocity of wave in medium B? V2 is, wow. I think you understand. I think you know how can you solve this equation. Do you remember that? Do you remember that formula? Now, solution. From V1 lambda 1 equals to V2 of lambda 2. Remember this relation. We obtained it from frequency, where we said frequency at the two different media is the same. And also, we use this formula to have what is required. What is required here? V2. Now make the subject V2. Then V2 will be equals to V1 lambda 2 over lambda 1. Here will be given max. Here will be given max. What is V1? 10. What is lambda 2? I think 1.5. You divide by lambda 1. Lambda 1 is 20. 2 meters. Sorry. 2 meters. What is the answer? Velocity in medium B, which we assume to be V2, is nothing but 7.5 meters per second. This is how you can calculate velocity V2. Now, at that point, my students, this is the end of today's presentation, where we saw the definition of wave velocity, but also we saw the relationship between wave velocity, frequency, and wavelength. After we saw how we can attempt different questions as wave velocity concerned. Hope you have understood, and this is the end of wave descriptions. Next time we're going to proceed with another part as wave concerned. See you. Bye.